All right, here is the exit ticket for lesson 10. Number 1, estimate the product. So that is one thing we have to do. Solve using an area model and the standard algorithm. Remember to express your product in standard form. All right, we have to do 4 different things. We have to estimate, we have to use an area model, we have to solve using the standard algorithm, and then we have to remember to express our product in standard form, right, which is a fancy way of saying number form. All right, well, let's get started. 33 2/10 times 21 is about, this is the part where we estimate. So remember, when we estimate decimals, we want to estimate to the whole number. So the whole number in 33 2/10 is 33. 2 tells 33 to stay where it's at, so we have 33. And then 21 is really close to 20, right? It rounds to 20. So 33 times 20, well, we have a basic fact of 33 and 2, so 33 times 2 is 66. And then we add that 0, so it's about 660. Now we want to represent and solve using an area model and the standard algorithm. An area model looks like this, we know, right? And what we want to do is we want to decompose 33.2, okay, or 33 2/10. If we want to represent that number in tenths, we can say that 33 2/10 is the same as saying 332 tenths, right, to get rid of the decimal. And that number can be broken into 300, 30, and 2, right? And that is in tenths. It's really important to have that label there. Okay? And then 21 can be broken up into 20 and 1. So we just multiply like we do any other area model. 1 times 300, 1 times 3 is 3. We add the zeros. 1 times 30 is 30. 1 times 2 is 2. Okay? 20 times 30, 2 times 3 is 6, and we add our 3 zeros. Okay? 20 times 30, 2 times 3 is 6, we add 2 zeros. And then 20 times 2, well, 2 times 2 is 4, we add 1 0. Then we need to add across to get our 2 partial products. 300 plus 30 plus 2, there's only 2 in the ones place, only 3 in the tens place, and only 3 in the hundreds place. Okay? 6,640, there's zeros in the ones place, a 4 in the tens place, a 6 in the hundreds place, and a 6 in the thousands place. Right? Those are our partial products. So if we add our partial products, we get 2, 7, 9, 6,972. But remember, that's in tenths. Okay? Now we need to solve using the standard algorithm. So over here, we're going to set it up. 332 times 21. Remember, this is in tenths. Okay? 2 times 1, 2, 1 times 3, 3, 1 times 3, 3. That matches. We put our placeholder down. 2 times 2 is 4. 2 times 3 is 6. 2 times 3 is 6. And those partial products match, so it's a good sign that we're doing it right. 2 plus 0 is 2. 4 plus 3 is 7. 6 plus 3 is 9. And 6 plus nothing is 6. So we got the same answer, 6,972 tenths. Now, how do we write that in standard form? Well, we have to put the decimal back, because tenths tells us there's a decimal in that number, right? You have to think, how many place values does tenths represent? Well, tenths is 1 place value, right, after the decimal. And if you look in A over here, and change colors so you can see where I'm pointing, over here, we see 1 place value behind the decimal point in the original problem. So we need to move the decimal 1 place value, okay, in this problem to do standard form. So it is really 697 and 2/10. Okay, 697.2 is our answer. All right, let's do that again with B. Okay? 1 7/10 times 55. 1.7 rounds to 2. 55 rounds to 55, right? We just keep that at 55. Oh, I'm sorry. We round that to 60. And so we have our basic fact. 2 times 6 is 12, and we add our 0 to get 120. Okay? Now we need to solve using an area model. So I'm going to set up an area model. Remember that we can decompose 1.5 into tenths. So 1 7/10 is the same as saying 17/10. So up at the top, we're going to break 17 into 10 and 7. And then I'm going to label it tenths over here so I don't forget that I'm in tenths. Along the side, I'm going to do 60. Okay? Oh, no, I'm not. I'm going to go back to my original number, 55. So 50 and 5. So then I multiply. In my area model, 5 times 10 is 50. 5 times 7 is 35. 50 times 10. 5 times 1 is 5 plus 2 zeros, 500. And then 50 times 7, well, 5 times 7 is 35, and I add my 0, so 350. If I add across 50 plus 35, I have a 5 in the ones, 5 plus 3 in the 10, so that's 8, so it's 85. I add across down here, 0 in the ones, a 5 in the tens, and then 5 plus 3 in the hundreds, which is 8. I'm going to add my partial products. 5 plus 0 is 5, 8 plus 5 is 13, and then 8 plus 1 is 9. So I have 935. Remember, this is tenths. Okay? Now I need to solve using standard algorithm. So I'm going to set it up. 17 tenths, put that label on here. Whoops. Okay? Don't forget the label. 17 tenths times 55. 5 times 7 is 35. 5 times 1 is 5 plus 3 is 8. I put my placeholder. 5 times 7 is 35. 5 times 1 is 5 plus 3 is 8. And then I add 5. 8 plus 5 is 13. Carry my 1. 8 plus 1 is 9. So I got the same answer, right? Which is good. A good sign I did it right. Now I need to convert into standard form, which is number form. Tenths represents one place value. I see one place value behind the decimal in the original problem. So I need to move the decimal in this answer over 1. So it's really 93.5 or 93 and 5/10. All right, number 2. If the product of 485 times 35 is 16,975, what is the product of 485 times 3 and 5/10? How do you know? Well, I'm going to look and compare these equations. I see 485 here, and then I see 35 and 3.5. Well, the difference between 35 and 3.5 is I can represent 3.5 with the number 35 if I say 35/10. So 35/10 equals 3.5, right? So if I know that, then I know that 485 times 35/10 must equal 16,975. Okay, so if I were to convert that into, and that would be tenths, right? Because we multiplied by 35/10. So then I'd need to convert that to standard form, right? Which would equal 1,697 and 5/10.